So we have quite a bit of folks here. So Suhani, Yuvam, Navya, Veer, Ranveer, Arav. Okay, all right, cool. We can get started. Arav, I'm not able to see your full face. Can you turn your monitor? When you're naturally working or listening to me, I need to be able to see your full face. That's the idea. Everyone else is good. Cool. Yeah, so the plan for today is we'll discuss the homework one, and then we'll move on to geometry. Okay, but before we get started, any major questions? Navya, I know you didn't understand which one was that? Absolute value related inequality and the telescopic cancellation, all that, right? So there are a few problems in this homework itself that will touch on those, but over time, I think that'll be clearer for you. So should we find anyone else specifically anything that's bothering? Suhani, how about you? Did you go through the homework, go through the recording, all that?
Yeah, I had some trouble with the quadratic functions.
Fine.
And also absolute value, but yeah.
Okay. So hopefully after we discuss the homework questions, things should be clearer. Let's see. All right. Where is my share? There it is. Okay. You all have the homework PDF, right, with you? So let's start with the first one, right? Quadratic equation minus 2 times x. I'll just paste it on the group anyway. You guys should have it. Okay, state the x-intercepts, find the y-intercept, equation of axis of symmetry, coordinates of the vertex, sketch the function. Okay, so this covers the full gamut of this quadratic function, right? So let's do step by step. So what does x-intercept mean? X-intercept means where it cuts the x-axis, right? So where does this function cut the x-axis? So first of all, it's going to be a negative downward going parabola. And it cuts the x-axis when x equal to -2 or x equal to 1. So these are the 2 points, x equal to -1 and x equal to 1. That's when it's cutting the x-axis. What is the equation of the axis of symmetry? Axis of symmetry will be halfway between the two roots. Right? So halfway between the two roots, average of -2 and 1 is -half. So the equation of the axis of symmetry equal to x equal to -half. The vertical line is x equal to -half. Find the y-intercept. Y-intercept is where x is 0. So the y value will be -2 times 0 plus 2 times 0 minus 1, which is, I believe, 4. Okay. So the coordinates of the vertex will be -half, which is the x coordinate that we just saw. And the y coordinate would be, sorry, this is the y-intercept, right? Y-intercept is 4, which means it passes through 0, 4. The coordinates of the vertex would be at x equal to -half. It is -2 into -half plus 2 into -half minus 1. So how much is this? -2 times, this is 3 by 2. This is -3 by 2. So in total, I think it is +9 by 2, which is 4.5. So it's slightly more than 4. So 0 is somewhere here, right? 0 is between -half and +1. So the y-axis is somewhere here. Y-axis is somewhere here. And we just saw that it passes through 0, 4. Just erase this a little bit here. This was -half, 9 by 2, which is 4.5. The y-axis was here. And this point was 0, 4. Okay, you don't have to be super precise, just so that you understand what's happening here. I'm just taking time. So it'll go through like this. I didn't draw a great looking parabola here, but the key points are these: where it cuts the x-axis, where it cuts the y-axis, what is the coordinate of the vertex, and then it's upward sloping or downward sloping. What is the equation of the axis of symmetry? Does it make sense to everyone? All good. Ranveer, did you get this one?
Oh, yes, I got it.
Cool. All right. Next one, solve by completing the square. X square plus 7x minus 4 equal to 0. Okay. Should I paste it, or you guys already have it, right?
We have it.
You have it, right? Okay. X square plus 7x minus 4. Completing the square, we went over that. So we'll read it as a square plus 2 into a into b, or p plus q whole square, whatever you want to take. So my q is 7 by 2 here. And now I want to add 7 by 2 whole square. And I'll do the same on the right-hand side as well. And then I have the minus 4 sitting here. And now this chunk is now x plus 7 by 2, the whole square. Okay. And then the minus 4 moves to the right side. So it becomes 49 by 4 plus 4, which is 65 by 4, I guess. 49 plus 16. And now I can take square root on both sides. So x plus 7 by 2 equal to plus or minus square root of 65 by 4, which is nothing but plus or minus square root of 65 by 2 outside the root. And now I can take the x, I can take the 7 by 2 to the other side and just say minus 7 plus or minus root 65 by 2. Okay, which is what ideally we should get using the quadratic formula also. Let's verify. The quadratic formula would be minus b plus or minus root of b square, which is 49, minus 4ac will become minus of 4 into minus 4, which is plus 16, whole upon 2a. Okay, I know you are you didn't completely go through the quadratic video or something. Don't worry, just follow along as much as possible. And then when you go through once more, I think it will become clearer for you. Okay, able to hear along well, Yuvam? All good? Okay, that's question 2. Anyway, maybe I'll just ask around a few of you to comment on some of these questions, right? Find the maximum and minimum value and the value of x when this occurs. Navya, did you do this one? Question 3.
No, I had a doubt in this one.
Yes, what's your doubt?
I didn't really understand how to find the maximum value.
Okay, so a quadratic, you understand that it's a parabola, right? It's either upward facing or downward facing. Now, in this case, because the x square coefficient is minus, it'll be the latter category. It'll be a downward facing parabola. And the maximum value is at the vertex, right? Just like the problem that we did, just the first problem was very similar. The vertex was the maximum value. So the vertex is always the maximum or the minimum, depending on whether it's downward going or upward going. Right? Does it make sense, Navya?
Yeah.
Right? So in this case, it's downward going, and therefore it is the maximum value. And then the value of the x at which this occurs is the coordinate of the vertex, which is minus b by 2a. The coordinates of the vertex is minus b by 2a, as we did here also earlier. We found the two. So in this way, in this problem, we did it in a different way. We said that it intersects the x-axis at minus 2 and 1, and we did the average of the two, right? Which will still give you the same answer. For example, if you do minus b by 2a in this case, if you expand it, how much will this be? Minus 2 times x square plus 2x minus x minus 2. So this would be minus 2x square. And this is plus 1x, right? When you multiply, it becomes minus 2x plus 4. So if you do the minus b by 2a here, minus b by 2a will still give you the same minus half that we got earlier. So two ways to find the vertex. If you know the 2 points where it cuts the x-axis, take the average of the two, or directly apply minus b by 2a. Veer, are you okay with both methods? Sorry, I didn't hear you too well, Veer. No, Veer, something on your audio side. All okay? Your voice is like a drag, or is it just me? Navya, are you able to hear Veer well, or is it just me? Not able to hear, right? Veer, can you say something? Hello? Okay. Just check on something on your side. So I'll meanwhile just continue. So minus b by 2a would be minus 4 by 2 times minus 2, which is 1. So the coordinates, the value of x at which this occurs is already answered. So this is 1. He didn't ask anything further. But if they ask you what is the y value, then it's just a question of substituting 1 here. So it's minus 2 times 1 square plus 4 times 1 plus 3. So it'll become 1, 5. Now, does this make sense completely?
Yes.
Okay, cool. So that was question 3. But if you're able to hear me, that's good. But if you want to ask me something, I think it's a bit of a problem right now. I cannot hear you. But if you are able to hear me along so far, that's good. But can you give me a thumbs up if you're okay? You are able to hear me, Veer? Veer, I'm talking to you.
So I think you wrote it.
Okay, cool. I can see your thumbs up now. Okay. Question 4. Reciprocal of a number and its reciprocal is 2, 1 by 30. Okay. Arav, did you get this one?
Yes, I think, yeah.
Okay. What are your answers, Arav?
Sorry, sir. No, this is question 4. I could not quite get this one.
Okay. Ranveer, how about you? Did you do this one?
Oh yes, sir, but
And what's the answer you got?
I don't know if I put.
Okay. All of you have your working readily with you guys. So let
Wait,
me
so was
yes.
it? I think I got 5/6.
5/6. Okay.
Yeah.
All right, let's check. So let the number be x. So x plus 1 by x is 2, 1/30. So let's simplify this as 61/30. So let's multiply throughout by x. So I have x square plus 1 equal to 61/30. Actually, let's multiply throughout by 30 also now. So 30x square, and let's bring the x to one side, minus 61x plus 30 equal to 0. Okay. Now, we can either factorize this. Factorizing would be, we need to find two numbers, a and b, that multiply to give the product of 30 and 30. That's how factorization works, right? The product of the x square coefficient and the constant, and which add up to 61. Okay. So if you are able to guess two such numbers, that's great. If not, we'll have to resort to quadratic formula. So let's see. Can anyone help? Okay. Is anyone able to guess two numbers that satisfy this property? Multiply to 900 and add to 61. Navya.
Minus 36 and minus 25.
Okay, 36 and 25. So in this case, I'm not worried too much about the signage. I'm just calling it minus 61, but you're right. It should be minus 61. Okay, the signage is more important for the product. For the sum, it's fine. Okay, yes, but minus 36 and minus 25 indeed. But let's say if you're not able to guess it, you can still do it by the quadratic formula. 36 times 25 is 900 indeed. Okay, so let's go with that. So 30x square minus 36x minus 25x plus 30 equal to 0. And then I can factorize, I can take 6x outside here. So that gives 5x minus 6. And then similarly from these two, I can take 5x outside. So that becomes 5x minus 6. So 6x minus 5 times 5x minus 6 is 0, which means either one of the two parts is 0. Either this is 0 or this is 0. So this gives x equal to 5 by 6, Ranveer, as you rightly said. But this gives x equal to 6 by 5. You need to write both answers. And sure enough, right? If a number and its reciprocal add up, then the reciprocal and its own reciprocal is back to the number. So x can either be 5 by 6 and the reciprocal can be 6 by 5, or the vice versa also. So there are two answers for x, 5 by 6 and 6 by 5. Okay, cool. And let's quickly solve using the quadratic formula also. So minus b plus or minus square root of b square. So 61 square, right? And we are not allowed calculators here. So one good thing we can do is we can do a plus b whole square, right? So a square plus 2ab plus b square. So there you go. So 3721 is your 61 square. minus 4 AC. So 4 into 900. That's easy. Whole upon 60. So it's 61 plus or minus square root of 4 times 900 is 3600 anyway. So if I'm subtracting, the balance is just 121 whole upon 60. So it's 61 plus or minus 11 upon 60. So 61 minus 11 is 50. Therefore, it's 5 by 6. 61 plus 11 is 72. 72 upon 60 is 12 goes 6 times, 12 goes 5 times. The same answers that we got earlier here. Okay. Cool. That was this. Okay, question 5. There are 3 parts to this. Find the equation with the function with the graph. Arya, did you can you help with the question A? Arya, are you saying something? I cannot hear you.
I was not too sure with this question, APC.
Okay, neither of them, or did you get any of them?
No, I didn't get most of them.
Okay.
No.
Okay, Veer, were you able to try this? If you're able to speak. No, Veer, your audio is still bad. Sorry, I'll skip over you. Suhani, did you do this one?
Oh no, sir, I had trouble with the quadratic function, so I didn't.
Okay. Who got this one? Who can help? Navya, did you?
No, I had a doubt in it.
Okay. All right. So let's discuss. So quadratic is all about symmetry. So here the problem says this is 5. 5 means what? It passes through 5, 0. Is referring this point where it crosses the x-axis. So this is 5, 0. And we know the vertex here, the minimum point is 2, minus 20. Right? What do we do know is the vertex is passing through the axis of symmetry, right? And now the graph is symmetric about both, symmetric about the vertex. Therefore, if this point is 5, which is 3 units to the right of 2, so this is 2, this point is 2, the vertex, right? And therefore, 3 units to the left of 2 would be this point. So this point would be minus 1, 0. Doesn't make sense, Suhani. So the vertex is halfway between the 2 roots. One root is 5, 0, or rather one root is 5, which is why it passes through 5, 0. The other root has to be symmetrically on the left side. Therefore, it's minus 1, right? And now that we know it's passing through minus 1 and plus 5, the equation of the parabola should be something like x plus 1 times x minus 5. So that minus 1 and plus 5 are roots of this. Do you understand this? Why x plus 1 and x minus 5 have to? So that minus 1 and 5 can become roots of this. Are you able to roughly follow along, Yuvam?
Yeah.
Okay, so this is of the form y equals this. Of course, I can have some multiplier on top of it, which I don't know yet. It can be 10 times, it can be minus 2 times, right? Of course, it's positive because it's an upward going parabola, but it could be some multiplier multiplying x plus 1 times x minus 5. Now, does this make sense? How I inferred the first step?
Yeah.
Right? And now I can use any one extra detail. So it passes through minus 2, minus 20. So when x is 2, so this is 2 plus 1, and this is 2 minus 5, right? Y is minus 20, and therefore my A is 20 by 9. So my equation of the quadratic is 20 by 9 times x plus 1 times x minus 5. Yeah?
Wait, so how do you get the 3 and the minus 3?
Because I substituted 2, minus 20. When x is 2, y is minus 20. So by putting 2 here and by putting 2 here, the y is minus 20. Yeah.
So why did you write like instead of like minus 1 you wrote positive 1, instead of positive 5 you wrote negative 5?
That's because, so let's say you have, let's take some other example. Okay, so suppose I have x minus 2 times x plus 7 equal to 0. What are the roots of this? X equal to 2 and x equal to minus 7 are the roots of this, which means if you put x equal to 2 or x equal to minus 7, that's when this equation becomes true. Correct?
Okay.
Exactly same idea. So when x equal to 5, this becomes true, which means this passes through 5, 0, which means x minus 5 has to be a factor of the quadratic function. Yeah. Cool.
Yeah.
Okay, let's go to the B part. Okay. Now, each problem is slightly different in its own way, but there's a lot of similarities also. Here he has explicitly given the equation of the axis of symmetry, x equal to 4, which means this vertex at the top is 4 comma something. I don't know what that something is, but I know it's 4 comma something. Okay, the same idea. So because this is 7 is 3 units this side, the other root should be 3 units this side. So the other root is 1, right? So it has to pass through 1 comma 0, just like this is passing through 7 comma 0. So using the same principle, it must be of the form x minus 1 times x minus 7 times some a that multiplies. And in this case, I know a is negative, right? Because it's downward going. So I can do a quick check. Suppose I did a silly mistake and I found a as a positive answer, then I know something is wrong. It's downward going. I already know upfront that a has to be negative. Okay, let's confirm. What is the extra detail that we have? We know it passes through this point, minus 2. Right? For points that pass through x-axis and y-axis, he won't give both the coordinates. He'll only say minus 2. It's understood that this point is 0 comma minus 2. Right? Ranveer, you're with me?
Oh, yes, sir.
Right? Which means if I substitute x is 0, y must be minus 2. So minus 2 equal to this guy. Okay, so what is this? Minus 2 equal to minus 1 times minus 7 is plus 7. And therefore, no wonder a is negative 2 by 7. So the final answer is minus 2 by 7 times x minus 1 times x minus 7. Yeah. Okay. Now the C part is slightly unique. We see that it passes through only one point, which is minus 3 comma 0. There's only one root, or rather is a repeated root. So minus 3 is a repeated root. For example, just imagine had the parabola been slightly downwards, for example, had it been, okay, let me just erase this. Sanvi, oh, just 1 second, Sanvi. I didn't see you. Did you just join, Sanvi?
Yes, sir.
Okay. You had a doubt, Sanvi?
Yes, sir. In question B, if you substitute x as 0, why does y become minus 2? I didn't get it.
Because the problem says it passes through minus 2 on the y-axis, which means it passes through 0 comma minus 2.
Oh, okay. Thank you.
Yeah, you probably missed that point. And Sanvi, turn on the video as feasible, please. I didn't see that you had joined.
Yeah.
Probably you just
yes,
joined.
sir. I'm in the car. I'll
Fine.
turn on
No
video.
worries. Okay, does it make sense, Sanvi? It passes through 0 comma minus 2. Now, back to question C. Okay, now it passes through minus 3 comma 0. Just imagine had it been slightly lower than this. Right? Then let's say, just imagine, I didn't draw it very close, but let's just imagine this is minus 3.1 and this is minus 2.9. Then in that case, this parabola would have been x plus 3.1 times x plus 2.9 and then times a, right? Usual stuff. Now, the only thing is now this 3.1 and 2.9 have come very even closer. And at one point they coincide to one number, which is 3. So it's become this x plus 3 times x plus 3. So they've collided into one root, or rather it's two roots, but collided into one, right? So it's a into x plus 3 into x plus 3. That's the form of the third equation, right? So now I also know some extra detail. What is the extra detail? That it passes through 2 on the y-axis, which means this point is 0 comma 2. So I'll substitute the same way as we did earlier. When x is 2, y is, sorry, when x is 0, I'm sorry, I made a mistake. When x is 0, y is 2. So 2 equals 9a, I believe, 9a, right? 9a. Therefore, a is 2 by 9, positive in this case, right? So I don't want to confuse with this answer, which is, this is for the previous problem, right? Okay, so a is 2 by 9. And therefore, the final answer is 2 by 9 times x plus 3 whole square, which is a quadratic. Okay, all of you good? Navya? Understood? All of them? Arav? Okay, that was question 5. Question 6, yeah, so telescopic cancellation at work here. Can anyone help with this? Whoever got this? Ranveer, did you get this one? A part or B, either one.
Oh, no, sir. Wait, could you wait for the question before?
Oh, okay, you had a doubt question before. Yeah.
Oh, yeah. So it said A. Wait, so then why would you put the 9A there? Like underneath.
This, okay, let me just repeat this again, right? So I came till this part. And then I saw it passes through 0, 2. So which means when X is 0, sorry, Y is 2. So same thing as we have been doing a few times now, right? Therefore, A is 2 by 9. Sorry, didn't follow your question, Ranveer. How is this any different from the previous two?
Oh, no, so I got
Understood, right?
it.
So it's very similar.
I just didn't realize you. Yeah.
Okay, cool. But Ranveer, while I have you, question 6, were you able to get either of the two parts?
Oh, no, so I didn't get how to do that.
Okay, so the first one is, the first instinct would be to get rid of the radicals in the denominator. How would we do that? By multiplying by the conjugate. For example, let's take one example here, right? So for this 1 by root 3 plus root 4, I'll multiply numerator and denominator by root 3 minus root 4, right? Okay, so I multiply root 3 plus root 4 by, okay, I can either do root 4 minus root 3 or root 3 minus root 4, but fine, I'll just keep the same order, right? So that it's easy to understand. So this is how I'll multiply and divide to remove. I know root 4 is 2, but in this case, let's in a general case, let's say it's not a perfect square, then this is how I'll do, right? So when I do this, what do I get? I get a plus b times a minus b in the bottom, which is 3 minus 4. And I get just root 3 minus root 4. 3 minus 4 is just minus 1. So this is root 4 minus root 3 in the numerator, right? Again, I'm not replacing root 4 with 2, just have it. So general idea is this. That's how I'll do everything. Similarly, if it's this guy, I'll multiply numerator and denominator by root 2 minus root 3. Same thing will happen. So in the bottom, it'll become a plus b times a minus b will come 2 minus 3. In the upper, I'll have root 2 minus root 3. So again, this will be root 2 minus root 3 upon minus 1, which is root 3 minus root 2. All of you see the pattern? Arya, you're okay? Okay, so now you can see the pattern, right? So in the first one, sorry, it'll be root 3 minus root 2. So this guy would be root 4 minus root 3. The first guy would be root 2 minus root 1. Okay, and so on. The last guy would be root 100 minus root 99. Now you see a bunch of cancellations. This root 3 cancels with this root 3. This root 2 cancels with this root 2. This root 4 will cancel with another root 4 somewhere here. What will prevail would be the biggest one and the smallest one, always, in telescopic cancellation, right? The smallest one in the first term and the biggest one in the last term. So it's root 100 minus root 1, which of course simplifies to 10 minus 1, which is 9. Okay. Now, the second question is exactly the same. Instead of 99 and 100, he says, let's not stop at 99 and 100. Let it go to a general term, n and n plus 1. So the last term here would be root n plus 1 minus root n. Yeah, Arab, just 1 second. I'll just finish this and then I'll be with you. So root n gets cancelled. Everything gets cancelled. What will prevail will be root n plus 1 and minus 1. So the answer will be just root n plus 1 minus root 1, which is 1. Yes, Arab, go ahead.
So sorry, I just the previous question.
As in question 5 or 6a?
6a.
Yes.
In the second step, when you wrote 1 minus root 3 minus root 4 in the numerator, why did you do so?
Oh, so it's not 1 minus, sorry. This one 1 times.
Oh, okay. Okay.
Okay, so forget this problem. In general, suppose I have a problem like root 5 upon root 7 plus root 3, something like this. Generally, it's good practice to not leave square root in the denominator. So there's something called we rationalize the denominator. How would we do that? By multiplying numerator and denominator by a quantity which will help us. What is that quantity? √7 minus √3 in this case, like the conjugate of this, as they call it. Conjugate is a quantity which, when multiplied with this by using a square minus b square, a plus b times a minus b is a square minus b square, results in an integer. So that all the roots have now been taken to the top. So this becomes, right? So this becomes √35. I mean, I can just leave it like this itself, or I can say √35 minus √15 by 4. Whatever it is, the bottom does not have root anymore. That's the main idea, right? Exactly same thing I'm doing. I'm multiplying by the conjugate. The conjugate of √2 plus √3 is √2 minus √3. Does it make sense?
Yes.
Okay. All of you with me? Any other doubts on this one? 6. Okay, cool. Let's move on. 7. Okay, yeah, 7 is an absolute value question, right? So now, yeah, maybe this might help clarify some doubts you had, right?
I got it.
You got this one? Okay, cool. What is your answer, Navya?
I got x is greater than 3.
X is greater than 3. Okay, fine. Let's verify. We get the same thing or not. Okay, so in any absolute value problem, break it down into 2 parts, right? When, okay, first of all, to begin with, mod of x plus 1, we know is a positive quantity. Always, right? Mod of x plus 1 will be a positive quantity because of the modulus sign. Modulus of anything, I don't even have to look inside. It will always be a positive quantity. It cannot be 0 because it's given to be in the denominator. So we are granted it cannot be 0, which means x cannot be equal to -1. If you get x equal to -1 as some part of our answer, we should ignore it. We should not allow it, right? So I can safely multiply mod of x plus 1 on the right side without changing the signage, because I know mod of x plus 1 is a positive number. Okay, now I can split into 2 different parts. This question into 2 different parts, right? Which is the critical point when x plus 1 is 0? X plus 1 is 0 when x equal to -1. So I'll split my analysis into 2 parts. When x is less than or equal to -1, and when x is greater than -1. I can put the equal sign anywhere. For example, I can have the analysis as x is less than -1 here. And I can say x is greater than or equal to -1 here, because either way at -1, it's 0. But even otherwise, in this problem, x equal to -1 is not even allowed. So we don't even have to worry. Okay, but let's go with this. Right? Let's go with this. For example, suppose the given problem was this, what I've boxed. In this problem, -1 is very much allowed, as in there's nothing breaking. If x equal to -1, there's nothing, no 0 in the denominator. So technically, these 2 problems are not equivalent, right? Because x equal to -1 is allowed in the second one. X equal to -1 is not allowed in the original question. But then anyway, it's subtle difference. Let's continue. So if x is less than -1, for example, x is -5, let's say, then -5 plus 1 is a negative quantity, which means absolute value should be negative of that negative quantity, right? So in other words, in this region, mod of x plus 1 is negative of x plus 1, because x plus 1 is negative, right? So the problem reduces to 3x minus 1 is greater than 2 times minus x, 2 times this quantity, right? Which is minus x minus 1. This is minus x minus 1, right? So I'm rewriting the same problem like this, right? So let's bring all the x's to one side. So the minus 2x comes to this side as plus 2x. And then on the right hand side, I have what? Minus 2 plus 1, which is minus 1. So x is greater than minus 1 by 5 is what I have here, which means if x is less than minus 1, in this region where x is less than minus 1, I'll accept all answers which are greater than minus 1 by 5. Now let's see whether that makes sense. Minus 1 on the number line is here. Minus 1 by 5 is here. I'm looking in the direction which is less than minus 1, which is this way. And I'm saying I'll accept all answers which are to the right of -1/5, which means I'm not going to find anything at all, because I'm starting to look at x less than -1 here, right? Out here, I'm saying I'll look at the region which is x less than -1, and then I continue along. I find while solving that I'll accept answers greater than -1/5, but there's nothing greater than -1/5 in the region I'm looking. Therefore, ultimately, there's no solution in this half of our problem. Okay, now all clear on this one. You're with me? Okay, Sanvi, following along in car?
Yes, sir.
Okay, now x is greater than or equal to -1 is the other part. So in this case, we know mod of x plus 1 will be just x plus 1 because x plus 1 is positive anyway, right? So the problem is simply as if I don't have the absolute sign at all. I'll just replace it with a simple bracket like this, right? If I did some silly mistake, please watch out. Last time I did some silly mistake and then everything was topsy-turvy. Okay, now this is x is greater than 3, right? Which means what? Now what am I saying in this half? As long as I'm looking to the right of -1, so -1 is here, 3 is here. As long as I'm looking to the right of -1, I'll accept all answers where x is greater than 3, which means I'll have to finally accept everything that's greater than 3. So it's only a subset of the portion I'm looking at. The portion I'm looking at is x is greater than -1. In that, only if x is greater than 3, that'll make me happy. So x is greater than 3 is the solution for the second half. Now we combine the first half and the second half, right? Potentially the first half could have had some solution as well, right? In this case, there's no solution. So the final answer is just x is greater than 3. So well done, Navya, on that one. Okay. Did you do something very similar, Navya, or did you do something else? Multiple ways to do this.
I did a method which took like lots of time. So I just took -2, like I put -2 on the other side. And then you simplify that way. So then you get x minus 3 divided by mod of x plus 1 is less than 0, is greater than 0.
Okay.
So then,
Yeah, I was just being fully thorough and just explaining. What you say is perfectly fine. Okay, let's just go through what she's doing. You did this one, right, Navya?
yeah.
And after this, what did you do?
You make like you have a common denominator.
Okay, you have a common denominator, but where do you get rid of the absolute value sign?
You don't get rid of it.
No, then you're lucky. So basically you just did this.
Yeah.
No, in this case, you got lucky. I can always frame a problem where you'll go wrong, right? In essence, you did not look at the absolute value at all. That's what it means, right?
No, when you're doing this, you get x minus 3 is x minus 3 divided by mod of x plus 1 is greater than 0.
No, but even here, won't you have to have modulus here?
Oh, yeah.
Right? So the problem is not, the modulus continues. When you take the common denominator also, modulus will continue here, right? Does it make sense? And therefore, you'll be back to, you'll definitely have to split into two different categories, right? Just because in this case, the left category did not yield any solution at all, right? And you happen to be on the right category without realizing, and therefore your answer matched. Does it make sense, Navya? Again, I'm not finding fault with you. I'm just saying be aware of, right? When you have absolute value, always divide up into two different cases. And that way you won't go wrong. Okay. Maybe I'll make up a question where it will make a difference. I'll do that in a bit. Okay, fine. Or I'll give some homework problem on that. That was question 7. Question 8. Before we go to question 8, let's. Is everything clear on question 7? Any doubts from anyone? All okay? Let's do question 9 first, because that's also another inequality problem. So since we are in the groove of inequality solving, we'll come back to question 8 later after 9 and 10. Okay, anyone got an answer on 9? Sanvi, did you get something on 9?
Sir, I don't have the answer right now.
Because you're traveling.
Yeah.
At home you have. Okay. All right. Arya, how about you?
I don't think I have it.
Okay. Anyone has an answer on this one? Navya, have you done this one?
No, I didn't do it.
Okay. Veer, go ahead, please. I'm very, very sorry, Veer. Yeah, I'm not able to hear you at all. And same is the case with everyone. So something on your side. Okay. So it's like you're talking like a drunkard. That's how I'm able to hear. Okay. So something wrong on no, not better. Even with your video off, it's not better. Okay. Maybe try reconnecting if that helps. You're at home, right? And you have a normal Wi-Fi at home, right? Nothing different. Sorry, Veer. Okay. Okay. Yeah, no, not good, not good. I'll just continue. Okay. So this question, the thing not to do would be to cross multiply. That's a common mistake everyone does. So the very first step, it's very tempting to do this. Do not do this. If there is an inequality, do not do this. Wrong. This is wrong. Why? Because we explained in detail, right? Last class. We don't know the signage of x plus 2 and x minus 2. When you multiply both sides of an inequality, depending on the signage of what you multiply, the inequality sign would change or not change, right? And since we don't know, we cannot cross multiply. The only difference in the previous problem was I knew that absolute value of x plus 1 is positive. Therefore, I could boldly multiply without changing the sign. Here I don't, there's no absolute value, therefore I cannot cross multiply. Then what's the best way? The thing to do is get everything to one side. So I'll get everything to one side. So 2x minus 3 by x plus 2 minus 2x by x minus 2. Again, the problems could be such that you might encounter problems where you would still get the correct answer without having to go through all this nonsense. That's because it's coincidental. The problem might be framed such that it didn't matter, but you can always frame a problem where it will matter. So you should take the right approach. Okay. So what is the right approach? Bring everything to one side, have 0 on the other side, and then take the common denominator. So x plus 2 times x minus 2, and then cross multiply. So what do I have here? 2x minus 3 times x minus 2 minus 2x times x plus 2. So how much is the numerator now? 2x square. If I can do it, 2x square, and then there is minus 4x here and minus 3x here. So collectively minus 7x. So please, if you find a mistake, please stop me rather than hold for long. Okay, I'm just doing it now with you guys. So plus 6, right? Minus 4x. Am I right? Minus 4x. Okay, all right. And then minus, what do I have here? 2x square plus 4x upon blah, blah, blah. Same thing. I'm not writing the denominator. So what does this simplify to? 2x square gets cancelled. Minus 7x minus 4x is minus 11x. Yes, Navya, mistake.
How did you get minus 7x?
I said 2x times minus 2, which is minus 4x. And then minus 3 times x, which is minus 3x.
Oh, okay. So
I just skipped that step. I did it mentally. So minus 4x and minus 3x is minus 7x. Okay. So it's minus 7x and minus 4x is minus 11x. And then 6 has nothing else. So 6 is just 6. And then this part. Right? Now, what do we do? This is what? Less than 0, right? Less than 0. Okay. I'll continue upstairs here. Now, what do? We do the signage test. What is the signage test? We look at all the quantities and see where each of them becomes 0. Let me just write this clearly. This is x minus 2. It's not very clear. X minus 2. Okay. So x equal to minus 2 is when x plus 2 becomes 0. X equal to plus 2 is when this guy becomes 0. And then in the numerator, I have what? 6 by 11. 6 by 11 is a fraction less than 1. So maybe 6 by 11 is here. Minus 11x by 6 becomes 0 when x is 6 by 11. Now, these three are my critical points around which my entire problem is going to revolve. So because there are 3 points, there are 4 regions. Now, we look at the signage in each region. Okay. Now, easiest way is to look at the far right, which means x equal to 100, let's say. Very safe. If x equal to far right here, 100, numerator is clearly negative 1100 plus 6, which is negative. So numerator is negative, right? Upon the denominator, the first term is 100 plus 2, which is positive. The second term is also 100 plus 100 minus 2, which is positive. Net, I have a negative number, which means in this region to the right of 2, the net signage is negative. And from this point on, things will alternate, plus, minus, plus. But I would still urge you to do 1 or 2 simple checks, right? Because again, there are cases when this alternating mechanism will not hold good. I'll touch on that when we get to that point. Okay, but largely they'll alternate between plus and minus. Let's check, for example, to the left of minus 2, let's take a number like minus 100. If we take minus 100, then the numerator is positive. The denominator is negative times negative, which is positive. So net is positive. Yes, Navya.
So for the denominator, which you've written x plus 2x minus 2, can't you simplify to x square minus 4?
I can, but what value is it going to add me? In fact, I like it better with x plus 2 and x minus 2, so that I know the critical points are 2 and minus 2. Yes, I can, but in fact, the reverse. If it's x square minus 4, I would want it to break it down into x plus 2 and x minus 2. Right? So that I can clearly distinguish the 2 points where it makes a difference. Okay, cool. So now that I've inferred the signage and the different parts, what is the one that I want? I want wherever it's less than 0. So my final solution would be wherever this is less than 0, which is here and here. So my final solution would be minus 2 less than x less than 6 by 11, or x is greater than 2. Okay, does it make sense, all of you? Okay. Ranveer, all okay? Arya, all okay? Arav? Okay, so that was question 9. Let's do question 10, which is also another inequality, but with quadratic. Okay. Quadratic, we'll get everything to one side, first of all. By the way, did anyone get this one? Who wants to call out an answer on this one? Veer, is it better now for you? Did you reconnect or it's still same? No good. Sorry, not your day, Veer. Maybe reconnect later, and as long as you're able to hear along, that's good at least. Okay, so this would be 3x square minus 8x minus 16 is greater than 0. Yeah. So this is the quadratic. Now, this is an upward going quadratic, right? So let's suppose it were equal to 0. So suppose this is equal to 0, not greater than 0. Then where would it cut the x-axis? The roots of this. Either we can factorize and solve, or we can do the minus b plus or minus. Let's do the minus b plus or minus. Minus b plus or minus square root of b square. So we are solving for the roots for it to be equal to 0. Minus 4ac. Minus 4 and into minus 16, which will become plus 4. Okay. Whole upon 2a, which is 6. So let's see what this big guy is here is. 4 times 3 is 12. 12 times 16 is 192. 192 plus 64 is 256, which is a perfect square, 16 square. So it's this, right? So the two roots are 8 minus 16 upon 6, which is minus 8 by 6, and 8 plus 16 upon 6, which is 24 by 6, which simplifies to minus 4 by 3 and plus 4. Okay, so what does this mean? It means if you have the coordinate axis like this, minus 4 by 3 is one root, and plus 4 is another root, and the parabola is going through this, and it's an upward going parabola because the x square coefficient is positive. Are you with me completely? You're with me? Okay, so it's upward going parabola, and now we are asking, when is the y value? So now we are back to the inequality. We are looking at y equal to 3x square minus 8x minus 16, and we are asking, when is y greater than 0? We solved y equal to 0 to find out these 2 points, namely 4 and minus 4 by 3. Now we are asking ourselves, when is the y value greater than 0? And then we get the answer from the graph. Y is greater than 0 in this section, which means as long as x is less than minus 4 by 3, or is x is greater than 4, that's when my y is greater than 0. Now, yeah, does this make sense to you completely?
Yeah.
Okay, everyone? Sohani, all good? I'm not seeing everyone's faces, guys. So if you can unmute and talk whenever, because a lot of people screen sharing as well. So not always I'm seeing everyone. So if you can just unmute and call yes or no, that'll help. Okay. Okay. That was question 10. Now we had only question 8 to look at, which is partial fractions. Should we do this? Yeah, we can do this. I didn't particularly teach this, but we should do this. Sooner or later, you're going to need this. Okay, so what is this guy telling? Actually, this can be solved either using the telescopic cancellation or using this, right? Let's use what he says. Find constants a and b, says that 1 by n into n plus 2 is a by n plus b by n plus 2. So let's simplify this on the right hand side. N and n plus 2, I can take common denominator on the right hand side. I'll start with RHS. So it becomes a times n plus 2 plus b times n. So if I collect all the n terms together, it's n times a plus b, because an plus bn. And then the constant term is just 2a. So he says find the constants a and b by n times n plus 2. Now I compare with what is given on the LHS. LHS is 1 by n into n plus 2. The right hand side and the left hand side must match. This guy should match my 1, which means what? So think of the right hand side as it's 1 plus 0 times n. It has no n term at all. It only has a constant, which is 1. So which means my 2a must match my 1 and my a plus b must match my 0. So there's no n term. So I can artificially put a 0 n. So a plus b is the coefficient of n on the left side, or rather in my expression here. And 0 is the coefficient of n in the other expression. Therefore, my a plus b must match 0 and my 2a must match 1, because that's the constant here. Doesn't make sense? Arav, you good with me? Okay. So which means a is half. And then I can substitute that here and say a plus b is 0, therefore b is minus half. So I get half for a and minus 1 by 2 for b. So it's half by n minus half by n plus 2. Right? So this is your a and b here. A and b. Okay. Now, how is this going to help? So for now, he just says find the constants. Now let's put that and see how it helps us in solving this problem. Right? So I can apply this throughout. For every problem, it's the same thing, right? The bottom is n and n plus 2. So 1 and 3, 2 and 4, 3 and 5, n and n plus 2. So for as long as the difference between the two terms is 2, every fraction can be represented as half by n plus minus half by n plus 2. So I'll do that for every expression. So what am I going to do here? So I'll write this as half by n plus minus half by n plus 2. I'll do the same thing here. Half by n plus minus half by n plus 2. Half by n plus minus half by n plus 2. And so on. Maybe I'll write one more and then the next one will be clear. Minus half by 6. And so on. Now what's going to happen? The same telescopic cancellation. Minus half by 3 will cancel off with plus half by 3. Minus half by 4 will cancel off with plus half by 4. And so on. All the way, right? And minus 1 by this will cancel with something to come and so on, right? What will prevail would be, again, like we said, right? The very first and the very last. But in this case, there are two terms, right? Which are not cancelling. Half by 1 is also not cancelling. Half by half is also not cancelling. So you just have to be careful how many terms are cancelling, how many terms are not cancelling. So what is not cancelling is the first term in the first expression and the first term in the second expression, right? Half by 1 and half by 2 are not cancelling. So similarly, what will not cancel at the far end would be the first term in, okay, so this will end. So towards the fag end, you'll get something like half, the very last would be half by n plus minus half by n plus 2. The one before that will be half by n plus 1 plus minus half by n plus, sorry, this will be, I'm sorry guys, my handwriting is getting horrible here. Okay, maybe this is not so needed. So half by n minus 1 it will be, and then plus minus half by n plus 1. Okay, so so what will finally prevail would be the half by 1, the half by 2, and then in the subtraction term it will be this guy and this guy, the second term of the last two. So minus half by n plus 1 and then minus half by n plus 2. You can work it out and you can see it for yourself later. I'll just meanwhile make space here. Don't worry too much about this, guys. So I think you're okay to skip this also. Maybe should have. It's not that it's difficult. Okay. So what will prevail will be the first term, which will be half by 1, and the first term in the next expression, which is half by 2, and correspondingly the second term in the last two expressions, half by n plus 1 and then half by n plus 2. So this is what we get. So half plus 1 by 4 is 3 by 4, and this is 1 by 2 times n plus 1, and this is 1 by 2 times n plus 2. That's exactly what he has here, right? 1 by 2 times n plus 1, 1 by 2 times n plus 2. Okay, all right. We'll switch gears right now to go to geometry, but any other questions from the first class that we did? Open to all. Any question? You're able to hear me well, right? Even if you cannot ask questions, that's fine. For today, that is. Right? You're able to hear me along fully. Yes. With a thumbs up. Okay, good. Okay, so it's a different issue why I'm not able to hear you, but you can fix it next class. Okay, okay. Let's switch gears to geometry. Okay, so we have quite a few topics to touch on in geometry. The very first, fundamentally, we have to cover triangles and related properties well. Okay, so triangles you can either classify based on acute, right, obtuse. Okay, you can also classify as scalene, isosceles, and equilateral. Okay, equilateral. Okay, now not all combinations will be possible, right? Can a scalene triangle be acute? Yes, it can be 50, 60, 70 degree triangle. So this is possible. Can a scalene triangle be right? Yes, we know a 3, 4, 5 is a typical right angle triangle. So this is possible. Can a scalene triangle be obtuse? Yes, very much possible. I can have an obtuse angle triangle where this is 3 and this is 4 and this is maybe, let's not take 3 and 4. Let's say 3 and 5 and this could be 6, for example, right? So this is also possible. What is not possible, we'll rule it out. Now, equilateral triangle has to be only 60, 60, 60. So this is only possible way is equilateral being right, equilateral being acute. Equilateral cannot be right, equilateral cannot be obtuse. An isosceles can be any of the three again, right? An acute angle right triangle would be, let's say 80, 50, 50, right? And then if it has to be right angle and isosceles, this is very famous, 90, 45, 45 is the only possibility, right? For it to be isosceles and right angle triangle. Obtuse angle triangle possible like this. For example, this top angle can be 120 degrees and this can be 30, 30. Okay. Now, so in triangle, one very important property is sum of two sides must exceed the third side. So if I have A, B, and C here, the normal naming convention for a triangle goes as you use capital letter for vertices. Actually, that's true for any geometrical figure. Don't use small letters for vertices. Capital letters for vertices. And in particular for triangles, the side which is opposite to it takes the small corresponding letter. So small a is here, small b is opposite to capital B, and small c is opposite to capital C, right? So sum of any two sides will exceed the third side. For example, A plus B will exceed C, B plus C will exceed A, C plus A will exceed B, right? But it's enough to say the largest side is smaller than the sum of the other two sides, right? Because that will be the main worthy battle, right? If a longer side is getting added with another side, obviously it will be bigger than the remaining third side. So the real challenge is, let's say in a scalene triangle, the small, medium, and large. The small plus medium will have to be larger, strictly larger, not even equal. Then the small plus medium must be bigger than large. And why is this? This is because, let's say you have, how do you form a triangle using, let's say, 3 sticks? Let's say I have 3 sticks of length like this, and like this, right? So if I lay out the first one, and then I lay out the second one, like even flat like this is much longer to complete a triangle. So for us to form a triangle, right, even if we lay these two flat out at 180 degrees, this length is smaller than this length, then it cannot form a triangle. That's why this basic thing comes from. The small plus medium must be bigger than the larger for the triangle to be formed. Okay. Okay. Now there are, I don't know why I was erasing this, but that's fine. Okay. So there are four main lines in a triangle that you should be aware of. One is median. One is angle bisector. Okay. One is altitude. Another one is perpendicular bisector. Perpendicular bisector. Okay. So let's understand some key properties of each of them, right? I won't cover all the properties, but at least the key ones. So median is from each vertex join to the corresponding midpoint of the opposite side. Okay. So from here, I'll join to this. And then the third one will obviously pass. Not obviously, it will pass. You can prove that it passes. For now, I'm skipping proofs and all that. It'll pass. And this meeting point of the medians is called centroid. So the meeting point of the medians is called centroid. Okay. The medians pass through centroid. So let's label these points also. So let's say the midpoint of this is D. Okay, this is the side small a, by the way. Okay, so I'll erase the side length so that it's easy. Okay, let's say the midpoint of AC is E, and let's say the midpoint of AB is F. Okay, now this G, which is the centroid is G, right? It's actually the center of gravity. If you form a cardboard box, and then if you want to hold the triangle ABC, if you want to form a triangle using a cardboard piece, and if you want to hold it in one finger, that has to be a G, the center of gravity of the box, or what should I say? That shape. Right now, the main property here is AG is to GD will be 2:1. So the centroid will split the median in the ratio 2:1, and that's obviously true for the other two as well. So BG is to GE will also be 2:1, and then the other one CG is to GF will also be 2:1. Same thing. Okay, so that's the main thing with the centroid. Next is angle bisector. Okay, so angle bisector, as the name suggests, let me just go here. I'll draw a triangle again. Okay, angle bisector bisects the angle, right? So if I have an angle bisector like this, which bisects this angle, so let's say this is 70 degrees, then it becomes 35 and 35, right? Now, an important property here is AB by AC will be BD by DC. It's an angle bisector. So the ratio in which the opposite side gets split is the same as the ratio of the two sides which this angle bisector is dividing. Okay, so AB by AC, you can see in length itself, AB is shorter than AC and BD is also shorter than DC, right? Now, this important property. Now, if I complete the other two angle bisectors, same thing with this angle bisector. So let's say this angle bisector goes like this, right? And the third angle bisector goes like this. It has to again pass through. I didn't draw it too well, so maybe it'll pass through somewhere here. Let's say reasonably. I think this is more reasonable. And then the third angle bisector, something like this. Okay. Now, this meeting point of the angle bisector is called the incenter, I. Incenter. Okay. Now, meeting point of angle bisectors. This is angle bisectors. Angle bisectors. Okay. Now, it's called incenter for a reason. It's the center of the circle that you can draw inside the triangle. So if this is the incenter, if I measure the perpendicular distance from here to this side, if I measure the perpendicular distance from here to this side and this, it'll all be same. And therefore, I can technically draw a circle which touches all of these three sides. So I'm able to draw a circle, and such a circle is called an incircle. So this circle is called an incircle. Okay, so I'll repeat again. The meeting points of the angle bisectors is called the incenter, and that incenter will be at the same distance from each of the three sides. So I can draw a perpendicular and measure the three side lengths. They'll all be identical, and therefore I can draw a circle inside that triangle which touches each of the three sides. And that circle is called an incircle, and that circle has a radius, right? And that radius, just 1 second, I'll just finish this. And that radius is delta by S. I'll just come to what delta and S is. Yes, go ahead, please.
Sir, is the incenter and the centroid like somewhat similar?
No, they're all different. All four of them are different. There are two more that I'm going to cover, right? Like I said, so median, the intersection of median is centroid, and the intersection of the angle bisectors is incenter, and then the two more to come. All four are different, but in certain special cases, for example, if an equilateral triangle, all of these will coincide into one. But in a general scalene triangle, there'll be different points, right? And each has a special property. Okay. Now, where was I? I was saying this radius R, which will be the same length here, here, and here, this perpendicular distance, right? That's the radius, right? Through which I can draw this incircle, will be same. Now, that radius is delta by S. Now, what is delta? Delta in the context of any triangle is area, or in fact, even a parallelogram or in geometry, delta is used to denote area. Okay. Area of what? Area of obviously the triangle in this case. So area of the triangle. The triangle. Okay, in this case, triangle is also a triangle delta, right? So area of the triangle, and S is the semi-perimeter. Semi-perimeter. Which means what? It's the average of, not average, what am I saying? It's the perimeter divided by 2, not average. A plus B plus C by 2. Small a, small b, and small c are the side lengths. You may recall, right? Small letters are used for sides, capital letter is used for the vertex. Just 1 second, just 1 second. I'll be back in 5 seconds. Okay, so I'm back. So the semi-perimeter is A plus B plus C by 2, and this delta by S gives the radius of the incircle. Okay, now, actually, Yuvam raised a good point. We'll come back to that. All the four can be the same point, especially in an equilateral triangle. We'll see that. Okay, let's move on. right? Now, how do you find the area of a triangle in general? We can use the heroine's formula, right? Area of a triangle is the heroine's formula you would have studied, S times S minus A times S minus B times S minus C, where S is the semi-perimeter, right? S is A plus B plus C by 2. Okay. Now, one confusion might come in the heroine's formula. What if S minus B turns out to be negative, let's say, right? It's A plus B plus C by 2. When I subtract B, how am I guaranteed that it won't be negative? It won't be negative for a reason. If I do A plus B plus C by 2 minus, let's say, B in this case, what if I take common denominator, it becomes A plus B plus C minus 2B. So it becomes A plus C minus B by 2. But then we said at the very front, up front, sum of two sides will exceed the third side. So A plus C is guaranteed to be more than B. Therefore, you won't have the violation of it being a negative number. Suhani, with me completely so far? Ranveer, why is your video off, beta? Turn on the video. Everyone, please turn on the video throughout the class, unless you have a strong reason to keep it off. Okay,
Oh,
Sam?
sorry.
Okay. All right, so that's the in circle. The third one is the altitude. So what is an altitude? If I have a triangle like this, not too many great properties with altitude, but if I have an altitude is a perpendicular drawn from the vertex to the opposite side. That's the altitude, right? I can draw an altitude from here to here, and I can draw an altitude from here to here. Okay, so this meeting point of altitude is called orthocenter. Okay, there are a few properties, but for AMC10, you don't need to know too much about it. So, or just know that orthocenter is the meeting point of the altitudes. Okay, and we'll move on with that, right? Now, the fourth one is which is important is the circumcenter, which is the meeting point of the perpendicular bisectors. Now, what is that? What does the word perpendicular mean? We understand it's right angle. That's perpendicular. Bisector also we understand. If something bisects into two equal parts, that's bisecting, right? Right? If a combination of both happens, as in a line is both perpendicular and bisecting, such a line is called a perpendicular bisector. So in the context of a triangle, suppose I have this triangle like this. Okay, now if I want to draw a perpendicular bisector to this base, right, let's say this is A, B, and C, it must first of all bisect BC, meaning it must pass through the midpoint of BC, and it must be perpendicular to BC. So this is the perpendicular bisector of BC. Likewise, the perpendicular bisector of the other one, let's say of AB, would pass through this and it must be perpendicular. So this is the perpendicular bisector of AB. And likewise for this one, perpendicular bisector of this, all three, no surprises, will pass through the same point, like as we have been seeing throughout the theme, right? So this meeting point of the perpendicular bisectors is, let me call this some point, let's say call it what? G, no, and G is already used, right? I'll just call H, okay? Doesn't matter. Okay, now this H is the circumcenter. Just like in center, it is the circumcenter. So what do you mean by circumcenter? Clearly, it's a center of some circle to come. But what circle? Now, H is a point where the distance from each of the three vertices will be same. So the length HB, the length HA, and the length HC, all three will be same. So I can draw a circle which circumscribes this triangle, right? Which means it goes outside this triangle. So I can draw a big circle like this, right? Of course, it's going to come very ugly here now, but right, you can draw such a circle which is outside, right? And that circle has a radius R, right? That R, which is the radius of this circumcircle, the circle that we draw is called the circumcircle. Okay, so this radius is ABC by 4 delta. ABC by 4 delta, where A, B, and C are the small a, small b, small c are the side lengths, and delta is the area. Now, one good check that I would want you guys to always do is something called a dimensionality check. Dimensional check means in any problem, not just this, right? Do the units make sense, right? So for example, I'm talking about a length here, which is the radius. Is the right hand quantity a length? Let's check. Small a is a length, right? Small b is a length, small c is a length. So we have length cube when you do the product of a, b, and c. And the denominator 4 is just a number, so it doesn't matter really, right? It's just a number, does not have any units at all. Delta is an area. Area is length square, meter square, feet square, inch square, some length square. And length cube by length square is indeed a length, which means at least it's reasonable. It passes the dimensionality check. For example, let's say you forgot the formula and you thought, is it a b c by delta or a plus b plus c by delta? Then this is clearly wrong if you had that basic check, because a length plus length plus length would be a length finally. And then you have a length square in the denominator, which means 1 by length. How can 1 by length be a measure of a radius when you are expecting it to be a length? Understood? Right? Sanvi, does it make sense, the dimensionality check? Okay, so back here in the earlier one also, we could have done the same thing. For the in circle, the radius was delta by s. Delta is what? Delta is an area, which is length square. And s is what? Semi-perimeter, which is just a length, right? It's a perimeter divided by 2. 2 does not have any dimensionality, it's just a constant. Length square by length is indeed a length. So always get into the habit of any problem doing some basic sense check of dimensions or units. Okay, all right. So of course, we'll cover all of these concepts again and again, but the 2, 3 altitude is okay, not too much to worry. But in circle, circumcircle, and the concept of the median, the centroid being a point which divides 2 is to 1, that ratio. All of those are important, as well as in a case of angle bisector, the opposite side gets divided in the ratio of the 2 sides which the angle is bisecting. Those are important concepts. Okay, all right. Now there are a few triangles which come over and over and over again. That's 30, 60, 90. So let's say this is 30, this is 60, and this is 90, right? So such a triangle, right? The ratio of the 3 side lengths would be, let's say this is x. This will be x times √3, and this will be 2x. Okay, and we can derive that very easily. Okay, how can, okay, maybe I'll just derive it quickly, right? I'll just draw the same triangle here, 30, 60, 90. What I can do is I can draw a symmetric triangle downstairs here. Another 30, 60, 90, just a reflection around this. Now, what do I have? This is 60. This is also 60. This is 90. This is 180. This is 30. This is 30. Therefore, this is 60. So I have an equilateral triangle here. The big triangle is equilateral. So let's say I started off with this x here. By symmetry, this is x. A reflection, this is x, right? And because this is 2x and this big triangle is equilateral, this has to be 2x. And this has to be 2x as well. And now if I focus on, let's say any one triangle, let's say this bottom triangle, I know this is 2x. I know this is x. By Pythagoras theorem, I can find 2x square minus x square, which is 3x square. So square root of 3x square is x times √3. So this becomes x times √3. So the ratio of the 3 sides in a 30, 60, 90 triangle is 1 is to √3 is to 2. And this concept comes countless number of times in all competitive math exams. So don't keep working out the measurements. Whatever is given, you will be able to infer the other 2, right? Not always the smallest one is given. For example, if the largest one is given to be 10, you immediately infer this is 5 and you infer this is 5 √3. If this beach wala is given to be 7, then you know this is 7 upon √3. So that when you multiply by √3, it becomes 7. And this is twice that, 14 upon √3. Okay. So knowing this ratios 1 is to √3 is to 2 is extremely important. Okay. Any questions so far, guys? All okay? Arya? Yeah. Arav, poor guy, almost nearing bedtime, right? What time is it right now? 11 o'clock for you or past that?
11.
11. Okay. Yeah, another 10 minutes and we should be done. class today. Okay. Now, the other important, it's anyway Saturday night, right? So you can sleep in late tomorrow. Okay. 45, 45, 90 is another important triangle. So which is right angle and obtuse. We went over that, right? So if this is right angle and obtuse, let's say this is x, then this becomes root of x square plus x square, which is x root 2. So the ratio of the three sides is 1:1 is to root 2. In a isosceles right angle triangle. Sanvi, all okay here? Okay. So you seem a bit distracted. That's why I was just asking. All okay?
So the window is open and my papers are fine.
Okay. So 1:1 is to root 2 is the ratio of a sides in a isosceles right angle triangle. Okay. What is it going to say? I lost my train of thought. Sanvi's fault, not mine. I'm sorry. Okay, fine. It'll come back to me. So yeah, these two ratios are important, guys. So always focus on those. In an equilateral triangle, okay, I think I have to resort to the physical line. Okay, this is equilateral triangle. Okay. In equilateral triangle, the area is √3/4 into side square. S is the side length. Now, where is this coming from? Let's say this is side. Now, this is I can draw an altitude, which will also be the median, which will also be the angle bisector, which will also be the perpendicular bisector. So in an equilateral triangle, all of them will coincide, right? So this is perpendicular as well as bisecting, as well as this angles will be by symmetry, same 30 degrees, 30 degrees, right? And it'll be the median, right? All four. Now I have a 30, 60, 90 here. This is 60 and this is 30 and this is 90. I can apply my 30, 60, 90 rule. So which means this is S/2. And sure enough, I know this is twice S/2, which is S. And this is √3/2 times S, or rather S/2 times √3. The smaller one multiplied by √3. So S times √3/2, right? If the altitude, this also happens to be the altitude. Therefore, the area is half into base into height. So half into the base is S, and the height is √3/2 times S, which is √3/4 times S square. Okay, so area of an equilateral triangle is this. Okay, yeah, now I remember what I was going to talk about. So we talked about the 30, 60, 90 and 45, 45, 90 as two right angle triangles, which are important. In general, Pythagorean triplets are extremely important. So Pythagorean triplets. Okay, so the common triplets you guys know are the 3, 4, 5 and the 5, 12, 13. But then this pattern actually continues if you observe the pattern, right? You can start. Okay, I'll give you one more and I'll ask you guys if you know the pattern. If you're able to see a pattern here, 3, 5, 7, obviously the next one is 9. Can you see anything for here and here? Can anyone help?
Well, and 15.
12 and 15. Okay, I'm not saying
Is
yes or
it
no.
40 and 41.
40 and 41. Okay, so you said 12 and 15, 40 and 41. Okay. Okay, 12 and 15. What is the logic, Navya?
I just thought that if it's 3, 4, 5, then you just multiply.
Ha,
that
yes.
number.
So you are right in that I didn't clarify. In the simplest form, after simplifying, it should be a triplet. So that way, yes, you are right. But yes, 40, 41. Who was that? Arya? Who was that? I'm sorry.
Sahani.
Suhani, excellent. Why is it 40, 41? What is the pattern?
I don't know, but I just remember seeing a triangle that had that.
Oh,
then-
great. Awesome. Okay, then we'll test you further. What is 11, something, something? Okay, now we have one more 40 and 41 here. Suhani is right. Does that help complete the pattern, guys? Ranveer, she didn't tell you this. Sitting at home. Ranveer and Suhani are twins.
It's 60 and 61.
Yes, exactly. What is the pattern, Navya?
So if you square the first number, like then if you add the other two consecutive numbers, then
Excellent, excellent. So she's saying 9 square is 81. If I split it into almost 2 equal halves, it's 40 and 41. 11 square is 121. Almost 2 equal halves is 60 and 61. Yeah, that's the pattern. But why is this? Why does this pattern work? Same thing. 7 square 49. 24 plus 25 is 49. So why does this work? So any odd number, which is the first part, can be expressed as 2n plus 1. Any even number is 2n. Any odd is 2n plus 1. Okay. So now first let's write our theory and then we'll see why it works, right? Our theory, or rather Nadia's theory, is she's squaring 2n plus 1. So 2n plus 1, when she squares, she gets 4n square plus 4n plus 1. And then she divides it into almost 2 equal halves. So 4n square plus 4n, if I divide, it's 2n square plus 2n. And then the other one is 2n square plus 2n plus 1, right? So she is saying the triplet is composed of 2n plus 1, 2n square plus 2n, and 2n square plus 2n plus 1. Namely, these two add up to give the square of this. Now, why is this? Why does this work? So let's verify. Suppose I square. Okay, let's call this A, B, and C. Okay, so it's easy. So I'm going to verify if C square minus B square indeed gives E square. I'm going to check this, right? So let's check. So I have 2n square plus 2n plus 1, the whole square, minus 2n square plus 2n, the whole square, right? So someone is chatting me. Who's this? Oh, okay. Veer, sorry, I'm seeing your message only now, beta, that you can hear me. Very good. Okay. I don't check Zoom chats much or WhatsApp chats much. This is way back from an hour ago, I guess. Okay. All right. Sorry. So this is C square minus B square, which is C plus B times C minus B, right? So C plus B would be, when I add these two, I get 4n square plus 4n plus 1. No surprise. That is actually the square. And the difference C minus B is 1. And indeed, it is the 2n plus 1 whole square, which is what I'm expecting, right? Does it make sense? So when I subtract C square minus B square, I get C plus B times C minus B, which is in fact indeed A square, which is why this triplet works. Okay, all of you, you're with me completely?
Yes.
Okay, all right. Now, this is not the only family of triplets, of course, as she was telling, right? I can take any number and multiply it by some number. For example, I can multiply this by 10 and say 30, 40, 50 is a triplet, right? But other than that, in the simplified form, if I remove all the common factors, even then, this does not give the complete list of triplets. For example, I can call out a triplet which is not in this family. 8, 15, 17 is a triplet. Right? Again, all of these triplets are important to remember, right? So Suhani, for example, she recalled 9, 40, 41. In some other problem, there'll be a right angle triangle, there'll be some 41. For a random person, 41 would not mean anything. But Suhani will know, I have seen 9, 40, 41. Maybe it's giving me a hint that one of the sides is 40, and she'll work it out from there. A hint is all that takes to unravel a problem, right? The first hint is very important. After that, it becomes any knot that you have, that's how it is, right? The very first unplugging is difficult. After that, it comes out very easily. So recognizing that 41 is a triplet and it's a hypotenuse of a triangle is important, right? Same way, all of these small numbers, you can 8, 15, 17 is a triplet. You can check that, right? 8 square is 64. Right, 64 plus 225 is indeed 289. And I've told you guys to remember all the perfect squares till 1000 at the very least. If you can remember more, that's better, because competitive maths like AMC do not have calculator. Okay, so what is this pattern? A more general pattern is, I'll come down here. Okay, a more general pattern of generating triplets is actually very interesting. I can take any two numbers, P and Q. Okay, P and Q. Let's say P is greater than Q. Okay, I can form three numbers: P square minus Q square, 2PQ, and P square plus Q square. These three will be triplets. As in, let's verify. If I take P square minus Q square whole square, and if I add 2PQ the whole square, let's see what happens. So this is P power 4 minus 2P square Q square plus Q power 4. And this is 4P square Q square. So the 4 and the minus 2 add up to give plus 2. So which is this, right? Which is P square plus Q square, the whole square, which is this guy whole square. So this is a triplet. I can take any three numbers, I can do this. For example, if I take a P as 4 and Q as 1. So 4 square minus 1 square would be 16 minus 1. 2 into 4 into 1 would be 8. And P square plus Q square would be 17. So that's a triplet. Okay. Now the triplets that we saw earlier will also be in that, right? For example, if I take P as 2 and Q as 1, right? So 2PQ would be 2 into 2 into 1, which is 4. P square minus Q square would be 4 minus 1, which is 3. 4 plus 1 would be P square plus Q square. That's a common 3, 4, 5 triplet, right? So this is a triplet. Remember this: P square minus Q square, 2PQ, and P square plus Q square. Okay. Pythagorean triplets are done. Pretty much most of what you need with triangles is done. And then we'll continue in next class. I want to do a lot of properties with quadrilaterals. Right, the entire family, parallelogram, rhombus, all of you know this, but just want to plug in any minor gaps you guys would have, right? And then hopefully we'll be done with geometry easily. And one more topic I'm thinking, by next or next to next class, we should finish all the basics, and then we'll move into each topic. For each topic, we'll deep dive and do problems specialized in those topics, right? That'll be the plan for the next several weeks. Okay, all good. Any doubts before we wrap? Veer, can you just work on your this thing better sometime? But good that you're able to hear me, but I want to be able to hear you so that you can ask questions. Okay, see you guys next week. I'll send the recording as usual. Okay, bye.
Thank you. Bye.